Hello everyone, in this question, in Young's double slit experiment, the interference pattern is found to have as intensity ratio between the bright and dark fringes as 9. This implies that in this question it is given that the value of that is the intensity ratio of I bright by I dark, and this bright is called for maximum, so this is I maximum divided by I minimum, and this is equals to 9, that is we write here that is 9 by 1, so this is the ratio. And we know that the I maximum by I minimum is given by the formula, that is this is equals to amplitude. So this can be A1 plus A2 is the amplitude of the bright and dark, so this can be written as this is A1 plus A2 and this A1 minus A2, and this is whole square of amplitude is equals to that is ratio of intensity, and so this is equals to 9 by 1. So we can write the value that is A1 by A2 divided by A1 minus A2, and this is for maximum and this is for minimum, so this is equals to 3 by 1. By using the componendo and dividendo, we can write this value is equals to that is A1 plus A2, and this is plus A1 minus A2 whole divided by written as this is equals to A1 plus A2, and this is minus A1 minus A2 is equals to 3 plus 1 and divided by 3 minus 1. There imply this can be written as that is this will be cancel out A2 and A2, and there this A1 and A1 will be cancel out, so it becomes that is twice of A1 divided by twice of A2 is equals to 3 plus 1, this is 4, and this is 3 minus 1, this is 2. So this 2 will be cancel out and it becomes that is 2 by 1. So A1 by A2 is equals to 2 by 1. Now we have to find that the intensity, and we know that the formula of intensity, that is intensity I is directly proportional to amplitude a square of amplitude. So we write that is I1 by I2, and I1 by I2 is equals to written as this is A1 by A2 whole square. So and A1 by A2 is equals to that is the value is here that is 2 by 1. So A1 by A2 is equals to 2 by 1. So we put the value here, that is this is equals to 2 by 1 whole square, and it becomes that is I1 by I2 is equals to 4 divided by 1. So the ratio of intensity, that is I1 by I2 is equals to 4:1. Now we match this option. The intensity of individual sources, that is 4 and 1 units. So option second is the right answer. I hope you understood. Thank you.
Hello, we are given with a question, and the question says slit of width D is placed in front of a lens of focal length 0.5 meter and is illuminated normally with light of wavelength 5.89 into 10 to the power minus 7 meter. The fast diffraction minima on either side of the central diffraction maxima are separated by this much distance. The width D of the slit is what? Since we are given this, right? So we have a form, we are given with a slit of size D, right? And we have placed a lens here, and here it is a screen, right? So the distance between two first diffraction minima on either side, right, is, let's say it, the formula for that is 2 lambda d by small d, right? So what we can say is that from here 2 lambda d by small d, so capital D, what is capital D? The distance between the pattern where we are obtaining, that is the screen, and the slit, that is capital D, and lambda is the wavelength used. So that is equal to 2 into 10 to the power minus 3 meters, correct? So what we can write is 2 into wavelength is 5.89 into 10 to the power minus 7, right? into D. What would be the D? D would be equal to 0.5. Why? Because it is just placed, actually it is just placed here, right? So it will, like the rays are coming that are parallel, right? So it will be formed at the focus of this, right? So if this is the focus, then D would be equal to 0.5 meters by small d. We do not know that. We have to calculate that 2 into 10 to the power minus 3. Correct. So from here, what we can say is that D would be equal to this 2 and this 2 gets cancelled, right? So 10 to the power minus 3 into 10 to the power 7 by 5.8. Not actually this. This is 1 by D. D is equal to 5.89 into 0.5 into 10 to the power minus 7 plus 3. So that would be 10 to the power minus 4. So from here, D turns out to be equal to approximately equal to 2.945 into 10 to the power minus 4 meters. So this is the value of the slit size, right? So the value is 2.945 into 10 to the power minus 4 meters. Thank you.
The question is, in Young's double slit experiment, two slits act as current sources of equal amplitude A and a wavelength lambda. In another experiment, with the setup of two slits are sources of equal amplitude A and wavelength lambda, but are incurrent. The ratio of intensities of light at the midpoint of the screen in the first case to that in the second case is. So યંગના ડબલ સ્લિટના પ્રયોગની અંદર બે સોર્સ લેવાના છે જે કરંટ છે, કરંટ એટલે કે સુસંબદ્ધ ઉદ્ગમો છે, તેમના એમ્પ્લિટ્યુડ એ છે અને લેમ્બડા એમની તરંગ લંબાઈ છે. બીજાની અંદર અસુસંબદ્ધ ઉદ્ગમ લેવાના છે, બરાબર. તો એની અંદર બી એમ્પ્લિટ્યુડ એ અને લેમ્બડા છે. તો બંને તરંગો જ્યારે સંપાત થાય ત્યારે તેમની ઇન્ટેન્સિટી નો શું શોધવાનો છે, ગુણોત્તર છે શોધવાનો છે. તો શું થશે એમની ઇન્ટેન્સિટીનો ગુણોત્તર? તો ઇન્ટેન્સિટીનું ઇક્વેશન આપણને ખબર છે, જ્યારે કરંટ હોય ઇન કેસ કરંટ જ્યારે સુસંબદ્ધ ઉદ્ગમ હોય ત્યારે કેવું થાય છે, તીવ્રતા મહત્તમ થાય છે. તો તીવ્રતા મહત્તમ કેટલી થશે? તો કંપ વિસ્તારના વર્ગના સમપ્રમાણમાં, એટલે a સ્ક્વેર પ્લસ e સ્ક્વેર, તો 4a સ્ક્વેર એ એમની તીવ્રતા થશે. હવે જે સોર્સિસ જો અસુસંબદ્ધ ઉદ્ગમ હોય, બરાબર ને, ઇન કેસ સેકન્ડ કેસ આપણે લઈએ, sources are incoherent. તો ત્યારે શું થશે તેની ચર્ચા કરીએ. તો જ્યારે સુસંબદ્ધ ઉદ્ગમ નથી, અસુસંબદ્ધ ઉદ્ગમ હોય ત્યારે આપણને સરેરાશ તીવ્રતા મળશે I1 પ્લસ I2. તો સરેરાશ તીવ્રતા a સ્ક્વેર પ્લસ a સ્ક્વેર ઇઝ ઇક્વલ ટુ 2a સ્ક્વેર થઈ જશે, બરાબર. તો બંનેનો ગુણોત્તર કેટલો થશે? પહેલામાં સુસંબદ્ધ માટે I મેક્સિમમ, અસુસંબદ્ધ માટે I મિનિમમ ઇઝ ઇક્વલ ટુ શું થશે? 4a સ્ક્વેર બાય 2a સ્ક્વેર. તો 4a સ્ક્વેર બાય 2a સ્ક્વેર એટલે 2:1 થઈ જશે. તો આપણો જે આન્સર છે, આન્સર 1 એ રાઈટ આન્સર થશે, બીજા બધા ખોટા થશે. ઓકે, તો answer 1 is our right answer.
Hello, we are given with a question, and the question says, in a Young's double slit experiment performed with a source of white light, only black and white fringes are observed. In Young's double, first of all, I'll draw the setup diagram. Let's say these are two slits separated by a distance d, right? And the area or the size or the width of this slit, let that be W, right? So width be W, and we have a screen here, right? That is at distance capital D from the slits, and this is the central line passing through this, right? So here we would get the central maxima, and on both the sides, on either side of central maxima, we would get the fringes, right? When we use white light, we are using white light. So what does that mean is, since W is almost comparable to lambda, that is the wavelength used. Lambda is what? Wavelength of light, right? So when we use that wavelength of light, right, so W is almost comparable to lambda. So what happens is there is a diffraction of light. When we use a monochromatic light, that does not affect much, but when we are using a white light, that is a spectrum, that is a broad spectrum of light, right? So diffraction occurs, and due to diffraction there is a splitting, not diffraction, actually dispersion. I used it. Dispersion occurs, right? So when dispersion occurs, what is dispersion? Dispersion is the splitting of light into its constituent colors. So what happens is, when white light falls on this width, right, so it gets splitted up, we get white light at the center maxima, but we get different colored fringes, not black and white. We get colored fringes on either sides. So this statement is false. Thank you.